Hello and welcome to Apache TinkerPop's home here on Twitch. Today we have another TinkerPop Wide stream where we explore the wider TinkerPop community, looking at tools, libraries, graph systems built on the TinkerPop framework, or even applications built on those foundations. Today we'll be learning about ArcadeDB, which is a multi-model database using Gremlin for one of its query languages. We'll be hearing from Luca Garulli today, who will be taking us through this presentation. And Luca, we're really pleased to have you here today.
Likewise. Thank you, Steven, for having me. This is actually the first time that we present ArcadeDB publicly, so we are pretty excited.
Great. Well, we're happy that you chose this platform to make the debut, and I will get you going. We'll get your screen shared here, and I will get out of the way and let you do the talking. Thank you.
Thank you. All right. Let's see. All right. Okay, can you see the presentation?
Yeah, you're all good.
All right. So I'd like to start from a little bit of history about myself and about ArcadeDB. So I created the first database in 1998, a long time ago. It was an object database written in C++. The name was OrientDB DBMS. It was a long time ago, and it never reached popularity. We have like few clients, but it was only from 2009 that actually I started thinking about creating something totally different. And that's when I came out with the multi-model idea. So the idea was, so in 2009, if you guys remember, it was the beginning of the NoSQL age. So there were a lot of databases, new kind of databases like key value, document, column, graph databases. So every single model was super cool. And it was very specific for performance and modeling. But the problem I could see is that complex application actually needs something, need multiple databases at this point. So that's where I came up with the idea with the multi-model. So having something that is still generic purpose, like a relational database, but without a relational database engine. And so that was just an idea. So I just came out with, getting the old OrientDB, ODBMS engine in C++. I wrote like in Java. And it was just for fun. It was just a side project. I was CTO of a European company at the time. And actually was very cool to see how many people actually, of course, it was open source, Apache 2 license. A lot of people joined the project actually. And we started putting so many features in the OrientDB. And maybe that was one of the biggest mistakes. And we did a lot of experiments. A lot of legacy code actually is still in OrientDB today. And we love to get rid of it, but when you have a lot of clients in production, it's very hard to maintain and change things. So anyway, it was a very fun experiment, and we started in 2009, and it was in 2011 actually that we created the second Gremlin implementation ever. After Neo4j, OrientDB was the first graph database actually to implement the TinkerPop blueprints. At the time, there was blueprints, the name, so the API. And so after a while, a lot of users and clients actually were going into production. OrientDB was not meant to be production ready, but a lot of users didn't think so. So I received a lot of calls about getting support, but we didn't have the company. There was nothing, just a bunch of people on GitHub. So that's when I decided to create a company and start hiring actually a lot of contributors from GitHub, the most active contributors. So we created this company, and we get users, clients. Even if we bootstrap, we never get any VC funding. We were able to be profitable, and we get clients like Apple, Lockheed Martin, British Telecom, Barclays, and big companies. And sometimes we compete against Oracle and Neo4j, even though they were like 1 million times bigger than OrientDB. So the company grew up pretty well. And one day, Cadus Cloud, it was a client of OrientDB, decided to buy the company. So we were acquired by Cadus Cloud. And the Cadus Cloud actually, after only 4 months, had been acquired by SAP. I don't know how many of you knows SAP, but it's like a giant in the tech industry. And so SAP actually, buying Cadus Cloud, they found out that there is OrientDB, but they already have a database, SAP HANA. So it took me like, I think 3 years to figure out that there was not really room for 2 databases in the same company. So that's when I left SAP in 2021, and I decided to fork OrientDB to give like continuity to the project. But that was the best chance to create something new because we had so many ideas with all the committers in OrientDB to put in the engine. So many new things like mechanical sympathy and a lot of optimization, and you are able to do that today and not back in the day, like 10 years ago, 5 years ago. And there was a lot of legacy code that we want to get rid of it, but it was so hard with clients in production. So that's why I decided to rewrite everything from scratch with all this experience between OrientDB, DBMS, and OrientDB DB. So we start the engine from scratch, and we just get some part from OrientDB, like the SQL engine, and the Gremlin implementation. So that's why ArcadeDB was a brand new project, even though it was a concept from OrientDB. I mean, the ideas of the multi-model are pretty much the same. We just start evolving, few things that we can see in the presentation, and that's why in 2022, so last year, we started providing the replication by using Raft consensus algorithm, and we provide the Cypher, open Cypher implementation, the MongoDB, Redis, so you can actually query the database with so many different languages, of course, Gremlin and SQL. And in 2023, we're working with contributors and committers. Actually, they're very active into a lot of new improvement. And also the vector database is going to be the new model that's going to join ArcadeDB. Vector database is basically you store a bunch of vectors from models like AI models. So let's say that you can provide a history to your ChatGPT session, basically. So what is a multi-model first? So a multi-model is one database that actually is capable to manage different models at the same time. So in this case, there are other multi-model databases after OrientDB, and actually some of the databases around, they rebrand their own product as a multi-model. So we have document, key value, but the most important, in our opinion, is the graph model. The graph model is essential to manage like a lot of relationships. And I can see, I'm gonna show you how we manage the relationship in this index-free adjacency, why it's so important today. So why the multi-model? If we have so many other databases, they are very good at something. Because every single model, every single database type actually is very, very good in a few things. You can see, the key value and vector, they scale up pretty well, but the complexity of the data is not really there. Also the relationship, you cannot model a relationship. Then you have the graph model, they are really great in managing relationship, but actually you cannot have like complex data in the graph database. So with the multi-model, you have the best of pretty much all the single models in just one product. So with ArcadeDB, we did something more than OrientDB. So we not only provide SQL and Gremlin, but we also open up our languages to open Cypher. By the way, open Cypher today is translated into Gremlin. So actually, when you write a Cypher query from Neo4j, maybe you're migrating a project, actually is Gremlin running under the hood. And we also support GraphQL natively, so there is no external tool or like a Apollo server. GraphQL is in the server. We also have a partial support for MongoDB, and Redis is a partial support because we don't want to implement the whole feature of these both products. But for example, if you are coming from MongoDB project, or if your model is pretty much document based, could make sense if you query with using MongoDB syntax. It makes sense for you, especially if you have a lot of skill already on this technology. The same for Redis. If you have like key value type or like simple document, you can use any Redis driver for Rust or for Python in Redis. It will work because actually the driver, MongoDB Redis driver, they see ArcadeDB as a MongoDB or Redis server. All right, so I think the most interesting part of this presentation is how we how you can use the multi-model feature in Gremlin, because Gremlin has been designed to be a graph language, right? So how does it work with the multi-model? So let's start from the basics. In ArcadeDB, you can have a schema. So there is no Gremlin syntax for creating schema, even though there is like a proposal coming. Maybe in the future there's going to be a schema in Gremlin, but right now there is no schema. So in this example, we are just going to use a SQL. So we create like a vertex type vehicle, and then we create a car that extends vehicle. So you can add polymorphism into the schema. And this is very powerful. We borrow this concept from the object database model, of course. And the nice thing about polymorphism is that when you query the base type, let's say vehicle, you get every single instance of car, motorcycle, Formula 1, MotoGP. The same in Gremlin. If in Gremlin you query the basic type, you get all the instances that inherit actually the base class. So we map the label console of Gremlin is mapped as a type in ArcadeDB. You can do the same with edges. Actually, you can extend edges too. In this example, we just populate the schema with brand, owner, driver. We create like a bunch of edges, and we can also create properties for types. Oh, by the way, ArcadeDB works in schemaless mode. You just can create like a vertex type, let's say V, and edge type E, and the whole graph is going to be on these two types. Super basic. But the schema is very nice because it allows you to have constraints and to do powerful things like polymorphism. In this example, the first line, I create a property of the driver type called name. It's a string. And I start telling that, hey, this property must be not null. It's mandatory and maximum 128 characters. The same for the brand name. There is a date on the relationship owns is an edge actually, and is mandatory. And the last one, I'm creating an index on the brand name. This not only will speed up the queries, of course, if you're looking for a brand by name, but also is a constraint because it must be unique in the database. We're working on this new feature. It's gonna be ready maybe in a few weeks, that you can also define constraints on the edge ends. So you can define in the future, in the next release, that actually an edge, let's say the edge owns, can only connect owner and vehicle. The nice thing is that the polymorphism is still working here. So you can define that, can connect only between owner and vehicle, but any vehicle is fine. So any subclasses or subtype of vehicle is going to be fine. All right. So how does it work under the hood? I think this is I don't want to go too much in detail here. I was going back and forth removing this slide because maybe that's too technical. But for me, it's important to differentiate ArcadeDB against a lot of new databases that are around today. They're just a layer on top of RocksDB or other engines. And of course, you remove the most complex part, the storage. But at the same time, you have to adapt using a different storage, especially if it's a key value. So you have to map all the concepts on a key value. It's not always possible, especially if it's not transactional. So I just want to give like a quick look at how we store data and why this is important for the index-free adjacency. So every time you create a new type in ArcadeDB, ArcadeDB creates buckets under the hood. So a bucket is just a file. It's a physical file on the hard drive or SSD. So by default, when you create a type, Arcade creates 4 buckets. Why 4? Because in this way, you can parallelize writes. And for example, with our benchmark that runs on the continuous integration, we have a massive insertion of vertices, and ArcadeDB is able to insert more than 3 million vertices per second without any index, and 1.6 million if you define an index. So it's a very, very fast, especially because this is on not like a super hardware, but just a common computer, a common Mac. So it's super, super fast, thanks also to the level of parallelism they can use by splitting the insertion across multiple threads and across multiple buckets, mainly files, without any conflict. But in this case, I can use the buckets to differentiate my data in a logic way. So I don't need just, I have this file, just randomly feed this file. But this example, I have the type invoice, and I'm going to create a new bucket with name invoice 2023. So all the new invoices of this year, I'm going to store into this bucket. This is nice because by separating buckets, you are allowed to also locate these files on different storages type. Let's say that if you have a lot of data that you access very often, you can put these files on an SSD, or all data maybe on a hard drive, or you can also remove this data in just one click because it's just a matter of deleting a file. So keeping data separated is nice, especially because you don't need an index in this case. If your use case allows you to separate data in this way, having the different buckets actually is very useful. How to use the buckets in Gremlin. So by default, when you create a vertex, let's say invoice, ArcadeDB will decide which bucket is the best. But you can specify in the add v, instead of the type, you specify bucket as a prefix. In this way, ArcadeDB will store the new vertex into the bucket, right? Also the edge, the same for the edge. And you can query in the same way. You can create an index by the year, or you can just store on different buckets and then query, hey, give me all the vertices from these buckets, okay? It's also easy to create and drop buckets because they are just separate files. So it's very efficient to work with buckets in this way. So we store everything in this file, these buckets, and the bucket file actually is just a list of pages. By default, we use 64 kilobyte pages. We found optimal for most of the use cases, but when you create a bucket, actually, you can pass the page size. In some use cases where you have to, you're managing blobs or like large object, we suggest to increase this number, but usually 64 kilobyte is a good number for most of the use cases. So in this example, I'm creating two records of type account on the same bucket. So these two records will be on the same page, just they will occupy different slots of the same page. So when you create a new record in ArcadeDB, it can be like a vertex, an edge, a document, whatever, a blob, ArcadeDB assign a record ID, a read, automatically. This read, you can see here, is the format. Hash, the first number is the file number. So 13 in this case is the bucket number, and 44 is the position into the file. This means that this ID actually is a physical ID, and that's why they can never be recycled, because when you delete a record, you can never get the same position. So read are always unique. And this is the key to reach index-free adjacency. So when you create a vertex, when you create an edge with let's say with Gremlin, right? In this example, you are looking for this vertex by ID, these two vertices, and you create the connection friend of. You can see these are the vertices here, and with all the properties, you can see the read, type account, a bunch of properties. But what really matters under the hood is this layer. So when you store this, when you create an edge, ArcadeDB stores the outgoing vertex into this vertex. So you can see the record ID of the outgoing vertex actually is 1345, is stored in 1344, right? So you should think about these record ID as pointers. They're just persistent, but they're like pointers. So every vertex linked to each other once you create an edge. But also we have the connection between the vertex and the edges, because sometimes you want to query, you want to filter, you want to traverse by using edges. Maybe you filter by some edge property, so you need to cross actually the edge. But sometimes you just skip edges. You want to see which which vertices are connected, so you can just skip the edges because you are not interested into the property of the edge. And this way is way more efficient than was, for example, with OrientDB and other graph databases. They cannot they mandate you to pass to the edge all the time, even if you're not interested into the edge per se. So this is the index-free adjacency. We can actually traverse a graph by just loading records by using these pointers, this record ID. And this is huge because that means that we don't need an index. Usually, if you have like a primary key, let's say use UUID, and you want to connect two entities, you need an index that resolve this ID is this record. But with ArcadeDB, with this record ID, these pointers, actually, there is the physical location of the information. So you don't need an index at all. That means much faster insertion speed. And also when you traverse the graph, you don't pay the cost of looking up into the index. So loading a vertex on an edge by the pointer is a constant operation. It doesn't matter if the database has 3 records or billions. It's always the same time because you're loading a physical record from the exact position. So ArcadeDB already knows which area has to be loaded. Again, it's the log n, the classic speed for a balanced tree. If you have like a B plus tree, usually it's log n, but if you have different kind of index, maybe it could be worse. But so if you have like few connection, you don't see much difference. But when you have thousands, millions, or billions of edges connected, this is huge because it allows you to cross huge graphs in the speed of light. So that's why index-free adjacency is so important because it allows us to cross vertex edges in constant time, independent from the database size. And this is one of the main differentiation between ArcadeDB and other databases that allows a relationship, but they always use an index. All right. What about embedded? We have a lot of models. We have like the search engine, the vector database. And like, what about documents? So documents can be useful if you have like, you want to store data into like a vertex on an edge. So ArcadeDB allows to store embedded documents. And actually an embedded document can have multiple embedded documents. So you can embed documents without limitation. But the Gremlin API are not meant to use this this embedded document. So we should explore the possibility to use a property of properties that we never use actually. I remember it was in the original specs, but we never use in OrientDB. Maybe we can use it in ArcadeDB in this way. But right now we just extend the TinkerPop API with this new method embed. So in this case, you create like a vertex customer, you assign like an ID, and you call embed. So you want to create a new attribute, residence of type address. Address is a document type that you defined before. And you start populating the address, right? And this is the resulting document. If you convert it into JSON, this is it. So you have the residence actually is an embedded document. So this could be useful for if you have complex data to manage. And with Gremlin, we create this new method in order to allow this feature. Maybe in the future, Gremlin will allow embedded document, and we can just change our API to comply to the standard, with the standard. All right, so this is a Gremlin meetup, so we have to talk a lot about Gremlin, right? What about the Gremlin server? So if you already are a Gremlin user, you know that all your drivers, they interact with the Gremlin server, with one of the protocols that are available. With ArcadeDB, we decided to embed the Gremlin server into the ArcadeDB server as a plugin. So ArcadeDB allows creating, having a lot of plugins, the MongoDB plugin, the Redis plugin, you can turn on and off. Gremlin server is one of these plugins. So when you start ArcadeDB by specifying, hey, I'd love to have this plugin, Gremlin server, please use this plugin. The Gremlin server and the ArcadeDB server actually are living the same JVM, in the same process. So when you execute query from the client, it doesn't need to be sent to the ArcadeDB server and send it back with a lot of latency problem, marshalling the data. So they both are in the same JVM. So it's way more efficient than having separate. So usually this is the configuration that we suggest to our user. You can still keep the Gremlin server separated, but this is the best configuration for most of the use cases. And the same thing we can extend into the ArcadeDB server itself. In some cases, we start with some cases with OrientDB. This is the same with OrientDB. If you're familiar with OrientDB, you can do pretty much the same. We call in this case ArcadeDB box. Is a process, so JVM, that has a YAML application, the application within Java, Scala, any language on top of the JVM, and the ArcadeDB server in the same JVM. So you can start the ArcadeDB server with these 3 lines, super easy. And that means that when you query from your user application into the database, it's in the same JVM. So you don't need TCP/IP, marshalling and marshalling. You don't need anything of this. So everything is much faster, and you have 0 latency because the same object coming from the database is going into the application. It's so much faster, of course, than using any client-server mode. Not because ArcadeDB server is faster, just because you're avoiding the TCP/IP latency at all in this way. When you embed ArcadeDB server into your application, you can decide to open the classic port that ArcadeDB uses, so you can still connect with Studio into ArcadeDB server. You can connect with the Postgres driver. We have a Postgres driver into a execute query from outside into the server. So it works actually as a server. It's just your application doesn't need to involve TCP/IP to talk to the database. It's not client server anymore. It's just one unit. That's why we call ArcadeDB box, application and server in the same instance. Of course, if you're using Gremlin server is going to be in the same box. But what about what if I have like a bug in my application and it crashes the JVM? I crashed the ArcadeDB server as well, right? Yes. And that's why every single mutable operation in ArcadeDB must be done in a transaction. Our transactions are fully ACID, so in case there is a crash, any kind of crash, even if you kill -9 a process, ArcadeDB and the next restart will roll back the data to the previous state. But what if the server crashes? What about my user? How can you do replication? Actually, you can replicate ArcadeDB boxes. You can have multiple instances of an ArcadeDB and your user application. You can just replicate how many times you want. And that means you have the best of both worlds because you have 0 latency between the user application and the ArcadeDB server, and the server is still running in high availability. All right. Next topic. Maybe I'm going too fast. Just give me any feedback, okay? Maybe I'm too fast. Or maybe if you have some question, maybe we can stop a question or we can respond to all the questions later. Maybe it's better. GraphQL. So we have a native support for GraphQL, and this is pretty cool. So we see in other databases like Neo4j, they use like an Apollo server. It's an external component. So actually, when your client is executing GraphQL, is talking to the Apollo server, and the Apollo server is redirecting the request into your DBMS server, like Neo4j or whatever. So you have a lot of latency between your requests because you have to do this double step. With ArcadeDB, we implemented the GraphQL actually into the engine. So GraphQL is just another language, like Cypher, SQL, Gremlin, it's just another language, and is able to expose HTTP API, so you can actually query in a GraphQL way. This is an example, very simple, of the beer database that is going to be part of our demo. The open beer database. It's just a database of beers and the connection between beers and brewery. It's a free data set that you can download for ArcadeDB. So in this way, I define a type beer. You can see point number 1 with the ID. Uppercase ID means that it's the ID of Arcade. In our case, it's the record ID. I want to expose the name as a string and the category. The category actually is mapped as a relationship in the database. So the category, I'm defining that it's going to be an array of category object. And with this @relationship tag annotation, I'm telling the GraphQL engine, hey, this category actually you have to cross this edge or name as category in direction outgoing. So the GraphQL layer actually will execute a query for me. It will do a traversal and will return the object all for free with all the information. But actually, it's not just one object. It's made of information across a piece of graph. I can define multiple type of queries. In this case, I define type query and just beer by name. So I want to get a beer by its name. And I can test it. So I can execute just beer by name I pass a name, and that's it. You can see the result at the bottom. You can also redefine your type when you want. You can see in Studio the demo if you have time. So it's super easy. We support a lot of things in GraphQL. We're still working on extending our support to the whole spec. It's pretty big, but a lot of use cases, especially with read-only, are supported and are production ready. What about Gremlin? How Gremlin fits this picture? Well, you can execute a Gremlin query, Gremlin traversal, behind a method name. So like before, we defined beer by name, but now we are telling, hey, when this method is called, I want you to execute this statement from Gremlin. You see the Gremlin notation, gv as name equals name. And you can see here that the name actually is the name of the parameter name you define the GraphQL method. So we are able to actually read the parameter that are coming from the method. So it's very easy to create a query by using just parameters. So it's very, very powerful. You just write your Gremlin query and you expose everything as a GraphQL. You can see here it's pretty much the same result as before. Let's talk about high availability. So with OrientDB, we struggle a lot. I'm comparing a lot OrientDB because it's our experience, but we have a lot of users coming from Neo4j and the graph databases, so we know a lot of features of our competitors. But I'm mainly referring to OrientDB because it's the database that we start from. So with OrientDB, I think we did like 3 times a replication implementation from scratch, 3 times. The goal was to have like a multi-master replication that would be super scalable, super consistent, blah, blah, blah. It was very hard. And we still, I think we didn't do a good job because there is so much to be tested, because having like a real multi-master, consistent multi-master that works in every single case, it's very hard. And that's why most of the databases, they are actually consistent. They use a different protocol like Paxos or Raft. And that's why we decided to use Raft, because it was much easier, and actually the final performance of ArcadeDB distributed are much better than OrientDB. So with 5 servers, the same workload that we use for the client was 500 times better in ArcadeDB. So our approach is a leader follower or master slave fashion with some changes. So when you start a server, of course, it's the leader because there is no other server around. The default setting for write is the write quorum is the majority. That means that every time you write a record, a vertex and edge document, so every time you create a transaction, the server is waiting for the quorum to be reached in order to give the feedback to the client. So with one server, the majority is just 1, of course. If we start a new server, let's say that we start a server in Europe, the new server is gonna talk to the leader, and with the Raft election protocol, decide who is the leader. So this election process actually happens many times during the lifetime of the cluster. And also, like when a new node is connecting, when a node is leaving the cluster, or simply when there are timeout issues. When there are timeouts between servers, you can see from the log, a new election process is in place. So the leader usually is the first server that starts, but during the lifetime of the cluster, it can change to any server. With this example, so the server is starting, the election is pending, and after a while, the agreement is that, okay, US Miami server is still the leader, and the European node in Rome is the follower. So you can see the write quorum now is 2, the majority, because between 2 servers, the majority is still 2. But what happens if you add another node? Let's say we start like a node in Japan. Once it's connected, the write quorum now is still 2, because between 3 nodes, the majority is still 2. Actually, we always suggest to have like an odd number of servers, because in case of split brain, that is totally managed by the protocol, you still have a quorum. Okay, so you never have problem when the 2 part of the brain of the cluster join again, you have a conflict and you have disalignment in your data. So by using majority, usually is the best choice, and it's always consistent in your cluster. Okay. So how does it work with the leader-follower approach? So with the leader, all the writes must go through the leader, right? So the leader actually is taking care of writing the journal that is distributed to the other nodes. So if you're connected to a node that is not the leader, let's say the Japan Tokyo follower, you can see this client. When you execute the write transaction, so a transaction, I don't know, update, create, or some vertices or edges, the node transparently send the transaction to the leader and wait that the leader reach the quorum. When the quorum is reached, send a feedback to the follower again, and the follower gives the okay to the client. So it's totally transparent for the client. The client doesn't know what's going on, and he believes that every single node is a leader because you can read the write on every single node. But under the hood, we have to forward this message to the leader in order to maintain the consistency of the cluster. There are some optimization here, like you can tell, hey, I don't want to wait for the response. So you can do things more asynchronously with some settings to speed up the insertion, for example. But this is the default way that a transaction is propagated from the leader to the follower nodes. So what happens when a node is unreachable, let's say it crashes, or just the network problems, or just the server? Let's say that you are using an ArcadeDB box, your application is maybe in Java, you didn't do a good job, you have a garbage collector problem, you stop the JVM for, I don't know, 10 seconds, and the node is not online. So the node is, so for any reason the node is offline, all the clients connected to the node actually switch to another available node. So the client automatically connects to a different server, so it's all transparent for the clients. And when the node is up again, it's asking for a realignment to one of the servers. And until, so in the first phase, until the delta changes are implemented into the local database, the node is not online. But as soon as the database is aligned, the node is back online and works in the classic like it was before. So with this design in mind, it's very easy to just start new servers. There is no corruption of database. There are not all the problems that we experienced with OrientDB, and was very hard to fix because of the multi-master approach. But with the RAF protocol and the leader forward approach, everything is so much easier and way more rock solid than than was in the past with OrientDB. If you're using Kubernetes, we have a configuration file. It's super easy. You just do kubectl apply with the file that we provide in the distribution, and you can scale up and down the replicas as much as you want with just this command, like kubectl scale stateful set, like ArcadeDB server, and the number of replicas. So if the number of replicas is major than was before, Kubernetes just started new servers and they will join the cluster. If the number of replicas is lower than it was before for the previous configuration, some nodes are killed and the cluster is still up and running. So you don't see any changes in the cluster, so every node is still up and running. So everything is very, very smooth. And this is the first step from ArcadeDB to be in the cloud, in the marketplace of the major cloud vendors. We are still not there, but we're working to provide ArcadeDB image in the marketplace of Amazon AWS, Google Engine, and other clouds. So having this Kubernetes smooth scale up and down was, of course, the first requirement to be on such clouds. All right. Okay, well, it's time for a demo. That was pretty quick. So in order to start ArcadeDB, we can just use Docker, and you can find this line on the website, homepage, and just remember to open the 2424 and 2480 ports. If you're using the Gremlin server, also the 8182, we are passing the password for the root user, because with Docker there is no prompt asking you for the root password the first time the server starts, so you have to provide the password. In this case, play with data. And we are telling, hey, when you start, so we are declaring these default databases. When you start, please create a new database called importer. Use the user root, is the default use of the server, and import from this a URL. This is the URL of the database. It's a gzip OrientDB actually export. So ArcadeDB is able to import any Neo4j, OrientDB, a bunch of JSON files, CSV files. So the import is pretty powerful and recognizes automatically the kind of format of the file. So it's very easy to, just start a server with already a database in it. I think with the best way, just using the OpenBeer database, because it's a small graph, it's very easy to understand and how it works. Okay, or you can just clone the GitHub project and compile, maven clean install skip test, go into the directory and just start the server. That's it, super easy. All right, so let's actually start the server. Okay, let me see if I can share my, okay, let me share my console. Yes. All right, this is it. Okay, so this is just a fresh ArcadeDB installation, just come from GitHub and just compile, takes 30 seconds. And let's go into the directory where the binary are created and start the server. So I don't know if you can read it, but I just started the server with specifying the same parameter that was in the slide. So please, I wanna have the Gremlin server, the default password, blah, blah, blah. So the first time the ArcadeDB server starts is asking for the root password. Play with data, play with data. Right, so at the beginning, it's importing the beer database from the internet. So it's downloading this file from GitHub. It's installing the database. You can see all the vertices and edges. And you can see here, there is the Gremlin plugin and the Gremlin server actually started with all these settings. Of course, we still have the classic Gremlin configuration, Gremlin server configuration file. So you can modify the YAML file to specify different ports or different way, like different protocol, serialization protocol. So you can just use the classic Gremlin server files. All right, so the server is started, and you can see Studio is available at this address, pretty much the localhost 2480. So let's go here. Okay, let me share now my browser. Yes, this one. All right, I hope you can see. All right. Okay, so root, play with your data, that's it. Okay, so this is Studio. It's a graphic tool to explore the database, do a lot of queries. You can see the server. So basically, this is the main page. You can change the database between all databases available. By default, this is the imported. Is the OpenBeer database that we just imported for startup. So we have all these type of vertices. There are no actually complex schema here, no properties, just indexes configured here. Edges, no documents. See, this is the schema. And you can start doing some query, like, actually I can click beer and display the first 3 records of beer with all the connection. And you can see here, this is the classic graph representation. You can play with this, node, and maybe it's not cool because you just see the types here. So you can actually click. Let's see, click on this beer. You see on the right, you have all the properties. And you can actually customize the layout. So instead of the type as a label, I would love to see the name of the beer. And this is so much better already. You see, you can see the name of the beer in the vertex instead of the type. But I would love also to provide like an icon Do you have like a beer icon? Yes, of course there is. All right. Let's add there some border, so it's much better. Maybe the icon size a little bigger. All right. Let's do the same for the brewery. I want to see the name of the brewery and the style of the beer, the style name. What else? What else is missing? The category of the beer. Let's put the category name. All right. You can also play, like you can highlight some node, cut, or like get like it just, I don't know, I'm interested in this part of the graph. You can click on crop. So the rest of the graph will be removed from here. And you can see that now it's so much better looking. Like you can see the beer with the logo. You can do whatever you want. You can create new edges, extend the relationship. So you can work with the graph in this way. And once you're done with the, you can change the color, the size of the line. There are so many options here. It reminds a little bit some Graph Studio tool. Maybe it's more simple and more user-friendly because there are less options. And once you're done, you can export the settings. So you can export the graph as an image, as a JSON, but you can export it as the setting. So you can share the setting with other other colleagues, so you can see the same icon, images, and labels. So you can work on the same data set with other people sharing the same database. What else? Okay, of course, every query can be seen as a graph or as a table. So this is the same query. I can see like a rational base. You can see the record ID is right here. You can change some setting, like some fitting feature here. All right, so let's do some other query. So this is just SQL, right? SQL is pretty boring. Let's do something more, more Gremlin oriented. Let me see if I have some query here. Okay, so let's try. Actually, I think it's saved here. Okay, here you can see all the saved query. So you can do a classic GV. You can decide use Gremlin. These are all the available query languages. SQL script is like SQL, but you can separate the commands with the semicolon. So you can execute multiple commands. You can also do a transaction like begin, commit. That's the SQL script. Otherwise, usually SQL is fine. Yeah, so you can just do this. Oh, sorry, Gremlin. Of course, this is not SQL, syntax error. All right, so this is a GV, classic GV. You can see I got a bunch of brewery. This is pretty much random because I didn't specify any class. So in this way, you can see you can execute your Gremlin here. Of course, this is multi-line, so it can be like a complex query. You can also execute a Cypher query if you're familiar with, coming from Neo4j. This is the classic query match with the pattern matching. You have pretty much the same, right? And of course, the graph representation. In this case, I didn't return any edges, just the vertices. Okay. You can also do some GraphQL. So let's see the example that we did before. We saw in the presentation. So let's put GraphQL. I'm not sure if the model was, yeah, I think it should be installed. Okay, so I'm defining here beer in this way, right? The relationship. And this is my new method, like beer by name. Cool. Let's start this GraphQL. Done. Okay, looks fine. See the JSON, right? And now I want to query the beer by its name. So the schema, the GraphQL schema actually is defined. Now I'm executing this query. And you can see the query works, okay? But I can actually, I want to rewrite the query, not by using the GraphQL, but I want to use Gremlin here. So like in the presentation, I redefine the beer by name, but this time I want to execute a custom Gremlin query, this one. So I execute this, so now the query is being redefined. And when I execute again the same command, of course, it should change the name. It is working. So it's very easy to prototype something with the studio. Also, let's say that you want to execute some, let's say, this query. You can always see, the graph side, the table side, the JSON response that comes from the server, and you can see also the explain. Here, actually, let's do this again. Let's provide execution. As you see, this query has been provided this way. So fetch from beer type, but the type actually is made of 8 buckets. So you can see it's fetching from each bucket, and this is the nanosecond time from each bucket. And the limit projection, as you can see that this query actually was pretty fast from the database, just 70 microseconds. And most of the time is in the projection. Why? Because the projection here is I want both edges. So during the projection, this SQL actually was crossing the graph. Okay. You can also do a bunch of stuff for the server, change the settings. If you're running cluster, actually you can work with your instances. You can force a synchronization of the database, and you have some help for the API. You can use HTTP to deal with the server, of course, and there is some help. Okay, so I believe we are on time. Yes. So.
All right.
Great.
Very good. That was a really incredible walkthrough. I especially liked the history lesson at the beginning. It was kind of nice to see how ArcadeDB fits in with the kind of the decade-plus long lore of the graph community. I feel like there was a lot you could share on ArcadeDB. I mean, did we just kind of scratch the surface there with what you showed?
I removed so many slides because they were too technical, and nobody will be interested. It would just be so boring. But yeah, there are. So we are now into the vector database model. It's going to be interesting when you can actually store vectors in an efficient way with your data. So maybe your application is going to have like a bot, ChatGPT or whatever, and you can actually store this history in the database, or you can do full text search without full text. I mean, search by using the vector proximity. It's way more efficient in so many use cases. So we are working in a lot of stuff, and also the community has been great with fixing typo from the manual to actually implement the entire modules for ArcadeDB and functions. So it's an open source project, Apache 2, so it's free for any usage. And I would love to see someone of you guys joining the ArcadeDB community. So we are on GitHub, Discord, and so for now, thanks so much.
Good. I also really like the I like the philosophy that's taken here with supporting different query languages, protocols, and so forth. Which do you find folks using the most when they're building their applications? Do you have any sense of that? Like, are people using the Redis APIs? Are they using Gremlin? Are they using Cypher? What are they doing?
It depends where they're coming from. So most of the people are actually trained on Neo4j material because it's really good. So they know how to run a Cypher query. Or maybe they start playing with Cypher with Neo4j, and they discover that the Neo4j license actually is not friendly enough. So they want to find like a different implementation, and that's why they are going to use Cypher mostly at the beginning. But other users from we have a big client in MongoDB actually is using Gremlin for 90% of the use cases. So they are heavy Gremlin users. But I can say maybe 50% Cypher and all the rest across all the other languages.
I see. Yeah, that makes sense. And then what version of TinkerPop is ArcadeDB supporting right now?
It's the last official.
Okay. Good.
Yeah.
Were there any places in your implementation that could have been made easier by changes in TinkerPop?
Okay. Yeah, that's a good point. So while we were when we were working with user with Gremlin queries, we found some hotspot with Gremlin. I think I sent like a patch like 2-3 weeks ago. And we already patched our version of Gremlin, but we just shared with the main project was some with the iteration of elements. So, and we redefined some of the steps to use the index we have in ArcadeDB, or like we have for us the count is much quicker than actually counting resources. So the optimization under the hood is rewriting the pipeline into a more efficient pipeline just for ArcadeDB. So I've seen a proposal maybe 2 days ago about having all the steps with protected attributes, so it's much easier to extend. I would love that. I would love to, because we would love to extend some of these steps to be more efficient with ArcadeDB, because sometimes we have like middle optimization that would be nice if the Gremlin pipeline can use it.
Sure. Okay, that's interesting. I mean, that proposal did come from Janice Graph, I believe, and that makes sense. I mean, traditionally we've like opened those up. Like TinkerPop has opened those up on kind of a case-by-case basis. So if you did have a request for I needed to make project step work faster, that was just usually a request made. So we'll see how this discussion goes. By all means, feel free to add to that. There's the discussions happening on the dev list right now. So yeah, if other providers want to see that, then we want to hear from folks on that. So let's see, what else did I was making notes about the embedded documents. I noticed you did, so you added some syntax like an embed statement, or an embed method that was like hanging from a property. You can't use embed in Gremlin though, correct? Like you couldn't do g.v embed.
No, not from Gremlin, just from the Java API.
Okay, so I mean, a suggestion, if you do have like custom things like that, the way to kind of extend Gremlin right now with those kinds of things might be to use the Gremlin's call step that was introduced in 3.6. Okay. So where you could do something like g.v call and then say embed and then provide your document-based APIs or whatever you would like to get that stuff in there, if it was JSON or what have you. So call might be something you might look into for that.
Definitely.
Oh, it looks like there's a question here. To our comment. It's really Yeah, I'll pop this up here because I think it's worth noting. But so Cole Greer saying the multi-model DB concept is really interesting. It's cool to see so many different models can be supported efficiently from a single database. And yeah, I mean, I think that's always kind of the neat idea behind multi-model. It does fit in some cases and works pretty well. I think you kind of showed that with what you were talking about here today.
Yeah, I think the key is the index-free adjacency. If you don't have this kind of feature in the graph model, it's going to be like a Swiss knife that is pretty good at everything, but not really good on something specific. If you have this kind of optimization to map relationship, can be a super fast graph database if you want to just use for graphs with some extension. Actually, most of our use cases is a graph with some like embedding or some other feature, but mainly it's always a graph database, and in terms of use cases, it's very rare to see somebody that uses ArcadeDB as a key value or a document database only.
Oh, okay, interesting. I mean, that was a kind of a follow-up there. Do you find many users actively using all the different models at the same time, or is it just kind of treating it as one DB or another?
Yeah, most of the times there is the graph is a big part of the model, and a lot of time you can see documents, very few time key value. Yeah, the search is also very common. You can just index everything and you can search whatever you want, like a Google console in your database. That's pretty common too. But yeah, mostly graph, I can say. Most graph is 99% of the time is the model, is the reference model.
I see. I do say I liked how Studio looked. I like that crop feature. I'm not sure I've seen that before. That was like a neat idea. I think folks will take notice now that that's been shown. how about the explain feature? I saw when you looked at the explain, it showed like kind of the ArcadeDB explain. Is there a way to get at the, say, the TinkerPop explain and the TinkerPop profile as well?
Actually, yeah, I never actually exploit this the profiling of Gremlin, but if Gremlin allows to, has like some profiling information, yeah, it would be super easy to do that.
Okay, yeah, I mean, you can also go the other way. You can embed ArcadeDB profile information into the Gremlin profile as well. So like you can kind of approach it from different ways depending on what you want to show. Let's see. It's just maybe take a look at one other question here. I think this one's interesting. So why'd you implement the storage from scratch when you could use RocksDB like most of the new DBMSs out there?
Actually, it's a good question. Because we saw so many times that the issue is maybe in the storage. And if you look at this project, they use RocksDB, the main issue of these databases is that they have nobody touching that part, because it just works 99% of the times, but every time there is an issue, like a client in production, you cannot touch that part. You have to wait for the community to fix your bug. It can take months or years. So we need to have full control of the entire layer, in case there is an issue. And also we have a lot of experience with storage. So we started a long time ago, and for us was not only fun, very fun, but it's also in our skill set. So, and also we got a lot of things from RocksDB in terms of LSM index, works very, very similarly, but we're able to do more in optimization at page level by using mechanical sympathy strategies and having a super efficient way to serialize and deserialize data into the pages. So this was the main reason.
I see. Okay. Cool. I think that's about it. Why don't we kind of wrap up here? I definitely appreciate you coming on here and making the debut for debut presentation for ArcadeDB. I think that was all really interesting, and I think we're getting some thanks and in the chat, which is nice. Thank you everybody for watching and joining, and we'll see you all in the next one. Take care.
Bye.